Welcome back to the Nocturnal Astronomer. I'm Atlas Reed, your guide through the cosmos. This is a place for quiet minds, for those late hours when the world has slowed down and your thoughts turn upward. For anyone who has ever found that the scale, mystery, and wonder of the universe has a way of making earthly worries feel a little smaller. Whether you've been here before, or this is your first visit, I'm glad you're here. There is nowhere you need to be right now. Nothing pressing is required of you in the hours ahead. Tonight, we'll talk about you, not your worries or your to-do list. We'll move through the universe, layer by layer. By the end, I think you'll find that being small in a very large universe is, quietly, one of the better things about being here. Let's dive in. Part 1. The room you're in. There is a room around you right now. It has walls, a ceiling, a floor. It feels, as rooms do, like the natural size of things. We are creatures built to think in terms of arm's reach and familiar, human-sized spaces. But the room is not the whole story. Beyond the walls is a street, and beyond that, a neighborhood, a city, a continent. The continent rests on a sphere that is, by any ordinary measure, enormous. Rise above the rooftop in your imagination. Keep going. The city shrinks to a grid of lights, then a smudge, then nothing. The curve of the earth appears. Your room has ceased to exist as a visible thing at all. Astronauts who have seen Earth from orbit describe something researchers call the overview effect. It is a sudden cognitive shift, a sense that the borders and urgencies of the world below are small things, things the planet itself has no knowledge of. The psychologist Frank White named this effect in the 1980s. He gathered accounts from dozens of astronauts who felt the same thing. Unexpected calm, and a sense that whatever had felt urgent before launch was not as fixed as it had seemed. You are in a room, on a street, on a continent, on a planet that from 200 miles up looks like a single, seamless thing. Already, without leaving the solar system, the scale of your worries has begun to quietly shift. The Earth has a circumference of roughly 25,000 miles at the equator. The deepest ocean point sits nearly 7 miles below the surface. The tallest mountain rises nearly 5.5 miles above sea level. The planet is genuinely vast. And yet Earth is, by the standards of what surrounds it, modest. It is the fifth largest planet in our solar system. Jupiter is more than 11 times wider. If Earth were a grape, Jupiter would be a basketball. The Sun contains more than 99% of all the mass in the solar system. Everything else, all 8 planets, all their moons, all the asteroids and comets, makes up less than 1%. 1 million Earths could fit inside it. Your room, at this scale, is infinitesimally small, and the worries inside it, the plans and problems, the stresses and anxieties are smaller still. That is, if you allow it to be, quite a large relief. Part 2. The Sun and its Family. Our solar system is, on the scale of the cosmos, a modest neighborhood. 1 star, 8 planets, dozens of moons, and a great deal of empty space, all held together by the quiet persistence of gravity. Light travels at roughly 186,000 miles per second. At that speed, it takes about 8 minutes to travel from the Sun to Earth. When you look at the Sun, you see it as it was 8 minutes ago. From Earth to the Sun is about 93 million miles. Astronomers use this distance so often they gave it a name. Neptune, the outermost planet, sits at about 30 of these units. Light from the Sun takes 4 hours to reach it. Beyond Neptune lies the Kuiper Belt, a wide ring of icy bodies. Beyond even that is the Oort cloud, thought to extend 100,000 times the Earth-Sun distance from the Sun. Light would take more than a year to cross it. We have not left yet. If you placed the Sun at the center of a football field and scaled everything down, Earth would be a grain of sand 10 yards out. Jupiter would be a small pea near the 30-yard line. Neptune would be another grain near the far end zone. The solar system is overwhelmingly empty. If you removed every planet, moon, and asteroid and spread the rest evenly through the volume of space, the result would be nearly indistinguishable from the vacuum of open space. It is mostly nothing. And yet, within that mostly nothing, on a grain of sand 10 yards from center, every human being who has ever lived was born and died. Every song written, every quiet night of worries spent, all of it on the grain. Venus has a surface temperature hot enough to melt lead due to a dense atmosphere that traps heat. Mars hosts the largest volcano in the solar system, rising nearly 14 miles miles above the surrounding plane. These extremes are happening very far from you. Saturn's rings stretch nearly 175,000 miles from the planet's center, but are less than a mile thick in most places. If scaled to the width of a football field, they would be thinner than a single sheet of paper. The solar system is quiet in the sense that we are its only known observers. No other world hosts anything listening to the night. The ability to wander belongs, as far as we know, only to the creatures on the grain of sand. Part 3. The distance to the nearest star. The closest star system to our own is called Alpha Centauri, a grouping of 3 stars about 4¼ light-years away. A light-year is the distance light travels in 1 year, roughly 6 trillion miles. The nearest stars are very far. The fastest spacecraft ever launched by human beings has been traveling since 1977. It is now about 23 billion miles from the Sun. At that rate, it would take roughly 73,000 years to reach Alpha Centauri. Alpha Centauri is, cosmically speaking, our next-door neighbor. The Milky Way is roughly 100,000 light-years across. If the distance to Alpha Centauri were 1 inch, the galaxy would be about 4 miles wide in comparison. The closest individual star in that system is small, faint, and cool. It would be invisible to the naked eye, even from a modest distance. Most stars in the galaxy are like this. The dramatic ones we see at night are the exceptions, not the rule. The space between stars is not empty in the way a clean room is empty. It holds very thin gas and dust, the raw material from which new stars eventually form. The space between stars is not dead. It is patient. Light from the nearest star takes 4¼ years to reach us. When you look at it, you are seeing light that left its surface over 4 years ago. The star you see is the past. Astronomy is always a form of looking backward. There is a quiet quality to starlight worth holding. You are lying on this planet, and the light arriving near you left its source years, decades, or centuries ago. The universe is communicating across enormous stretches of time, and it does so without urgency. Stars are scattered through the Milky Way the way a handful of grains might be scattered across an area the size of North America, with miles of open space between each one. Drifting through the galaxy at random, you would rarely come close to a star. That spaciousness is not lonely in the way we usually mean. It is more like the quiet of a wide plain or the open ocean on a calm day. It does not press in on you. It opens outward in every direction. The nearest star has been shining for billions of years without knowledge of the things that trouble you tonight. That is not cruelty. It is freedom. The distance does not judge you. The universe simply continues, vast and patient, while you rest. Part 4. Our Galaxy, the Milky Way. On a clear night, far from city lights, you can see a faint band of light crossing the sky. This is the Milky Way. What you are seeing is the combined glow of billions of stars, too numerous and too distant to resolve on their own. The Milky Way is a barred spiral galaxy with a central structure from which long, curved arms of stars and gas spiral outward. Our solar system sits on one of these arms, roughly 26,000 light-years from the galactic center. The Milky Way contains somewhere between 100 billion and 400 billion stars. The uncertainty in that range is remarkable. We cannot count them individually. We estimate our own galaxy's population the way one might count trees in a dense forest from inside it. At the center of the Milky Way is a supermassive black hole where gravity is so intense that nothing, not even light, can escape once it crosses a certain boundary. Its mass is roughly 4 million times that of our Sun. This black hole is so far away that it has no meaningful effect on Earth or our solar system. It sits quietly at the heart of the galaxy and has done so for billions of years without incident. It is not waiting for us. It simply is. Our Sun takes about 230 million years to complete one orbit around the galactic center. In roughly 4.5 billion years of existence, it has completed only about 20 of these orbits. We are slow travelers in a very large place. The Milky Way interacts gravitationally with neighboring galaxies. The Andromeda Galaxy is moving toward us and is expected to begin merging with the Milky Way in roughly 4.5 billion years. This process will be slow, graceful, and unhurried. Stars in both galaxies are so widely spaced that their merger will not result in most stars colliding. The galaxies will pass through each other over billions of years, with stars finding new orbits without most of them ever coming close to another. The night sky contains roughly 5,000 stars visible to the naked eye under ideal conditions. This is a tiny fraction of the stars in the galaxy, which is itself a tiny fraction of what exists. What you see is a small, local, warm sample. That sample is enough to produce something remarkable in the human mind, a sense of scale. Knowing that each point of light is a sun, possibly circled by its own worlds, is enough to make the events of a single human day feel gently, mercifully small. Part 5. The Local Group and Beyond. The Milky Way is one of several dozen galaxies bound together by gravity into a structure called the Local Group. This group spans roughly 10 million light-years and is the gravitational neighborhood our galaxy calls home. The Andromeda Galaxy is the most distant object visible to the naked eye. It sits about 2.5 million light-years from Earth. The light arriving at your eyes from Andromeda tonight left that galaxy before the first stone tool was ever made. The Local Group is part of a larger structure called the Virgo supercluster, spanning about 110 million light-years. It contains thousands of galaxies. The Milky Way sits near its outer edge, in a quiet region with few large neighbors nearby. In 2014, astronomers proposed that the Virgo supercluster is part of an even larger structure. They named it Laniakea, a Hawaiian word meaning immeasurable heaven. It spans roughly 500 million light-years and holds the mass of 100 million billion suns. The largest structures in the universe are vast filaments of galaxies, sheets and threads of matter stretching hundreds of millions of light-years, with enormous near-empty voids between them. The universe, at its largest scales, resembles a three-dimensional web. The observable universe, the portion from which light has had time to reach us, is estimated to be about 93 billion light-years across. This is not the whole universe. It is only what we can see, given the age of time and the speed of light. Within the observable universe, there are estimated to be somewhere between 100 billion and 2 trillion galaxies. The uncertainty has grown as instruments improve and reveal more distant, fainter galaxies. The more carefully we look, the more there is. Each of those galaxies contains, on average, hundreds of billions of stars. The total number of stars in the observable universe is around 1 followed by 24 zeros. There are more stars than grains of sand on every beach and desert on Earth. You are one person on one planet, orbiting one of those stars, in one galaxy among trillions, in a supercluster that is itself a modest feature of something far larger still. This is your address. it is, by any measure, a very humble one. Any of your concerns are those of a single being in a quiet corner of something so large its full size cannot be written down. The universe will hold. You can put things down for a while. Part 6. The Age of Everything. The universe is approximately 13.8 billion years old. This comes from multiple independent lines of evidence, including the expansion rate of space and the properties of the oldest light we can detect. It is among the best measured quantities in all of science. A billion requires some scaffolding to approach. If you counted to 1 billion at one number per second without stopping, it would take roughly 32 years. To count to 13.8 billion would take over 400 years. The number is genuinely large. For the first roughly 380,000 years, the universe was too hot for atoms to form. It was a plasma, opaque to light. Then it cooled, atoms formed, and the universe became transparent. That moment changed everything. The light released at that cooling moment is still traveling through space today. We detect it as faint microwave radiation arriving from every direction in the sky. It is the oldest light in the universe. It is everywhere, arriving at your skin right now. The first stars did not form until roughly 100 to 200 million years after the beginning. They were enormous, burning hot and brief. They lived only a few million years before exhausting their fuel and seeding space with new elements. Stars are nuclear forges. Hydrogen fuses into helium, helium into carbon, and so on up to iron. Elements heavier than iron are made in the final violent moments of a massive star's life, then scattered outward into surrounding space by the explosion. The Sun formed about 4.5 billion years ago from gas already enriched by earlier stars. The calcium in your bones, the iron in your blood, the oxygen you breathe were all made in stars that ended before our Sun was born. The Earth formed from material surrounding the newly born Sun. The oldest known rocks are approximately 4 billion years old. Life appeared between 3.5 and 4 billion years ago, and for most of Earth's history, it remained microscopic. Modern humans, people anatomically identical to you, have existed for roughly 300,000 years. Recorded history spans about 5,000 years. The entirety of human civilization occupies less than half of 1% of the time humans have been here. Your life, measured against cosmic time, would not appear on any graph drawn at this scale. And this is not a tragedy. It is mercy. The universe does not hold you to account across geological time. It simply moves forward, patient and enormous, while you rest. Part 7. The Scale of a Human Body. We have been moving outward through space and time. Let us turn inward now, because the cosmos is equally vast in the direction of the small. The human body is itself a universe of almost incomprehensible intricacy. Your body is made of approximately 37 trillion cells. Each one performs thousands of chemical reactions per second. The number of cells in your body is roughly 3 times the number of stars in the Milky Way. You are, at the cellular level, galactic. Each cell contains a nucleus, and within it, a full copy of your DNA. Stretched into a thread, the DNA from one cell would be about 6 feet long. All the DNA in your body, laid end to end, would span the solar system roughly twice. Below the cell is the molecule. DNA is about 2 nanometers wide, 1/10,000th the width of a human hair. Biology at this scale requires tools no human hand can hold, and measurements no human eye can directly observe. Below the molecule is the atom. An atom is almost entirely empty space. If one were enlarged to the size of a sports stadium, the nucleus would be about the size of a marble at the center. The electrons move through the vast space around it. Your body is mostly empty space at the atomic level. The solidity of the chair beneath you is not a property of matter itself. It is the result of electromagnetic forces between atoms that prevent them from passing through one another. Matter is more space than substance. Below the atom are subatomic particles, and below those, in protons and neutrons, are smaller particles called quarks. Quarks are, as far as physics can currently determine, truly elementary. They are as small as anything we currently know how to look for. The atoms in your body have been in other things before, and will be in other things again. The oxygen you breathe right now has been breathed by creatures across hundreds of millions of years. Your atoms are borrowed. You are a temporary arrangement of old material. This borrowing is not something to mourn. It is something quietly wonderful. The atoms forming your thoughts right now have been part of the universe for billions of years. For a while they are you, then they will go on to be something else. You exist at the midpoint of scale. Above you, the cosmos stretches away in light years. Below you is the quantum world, smaller than atoms and stranger than anything in daily life. You are right where the interesting things happen. Tonight, you can rest exactly there. Part 8. Light, Time, and the Night Sky. The night sky is an illusion in the most beautiful sense of that word. When you look at a star, you are not seeing where it is. You are seeing where it was when that light left its surface. The sky is a kind of time machine. Light travels at approximately 186,000 miles per second. Nothing known to physics moves faster. Across astronomical distances, the travel time of light becomes significant. At cosmic scales, it becomes immense. The star Betelgeuse, a red supergiant in the constellation Orion, is roughly 700 light-years away. The light you see left the star 700 years ago. What it looks like right now is something we do not yet know. That information is still on its way. Betelgeuse is near the end of its life and will eventually produce a stellar explosion, briefly outshining the entire galaxy. Astronomers expect this within the next 100,000 years. It is possible the event has already occurred and the light simply has not arrived. The Andromeda Galaxy is visible on a dark night as a faint smudge. The light arriving at your eyes left Andromeda 2.5 million years ago. You are looking at a galaxy as it was before the first humans appeared on Earth. The most distant galaxies visible to powerful telescopes are seen as they were over 13 billion years ago, not long after the universe began. The telescope is a time machine aimed at the past. Every distance in astronomy is also a depth in time. The light reaching your eyes from distant stars has crossed distances no human being will ever physically travel. It has survived billions of years in near total vacuum, bending slightly around massive objects, shifting in color as the universe expanded around it. The expansion of the universe shifts light from distant galaxies toward the red end of the spectrum. This redshift is how we measure the distances to far galaxies and confirms the universe is expanding. Space itself is growing, carrying galaxies apart over time. There is something calming in a universe that is always gently expanding. It is not rushing. It does not have appointments or deadlines. It simply moves outward at its own pace, indifferent to the calendars that structure human life. The night sky is full of light, that has been travelling longer than the Earth has existed. The universe is not far away. It is here, all around you, passing through the walls of your room, arriving from every direction, quietly present, always. Part 9. What you are made of. We said earlier that the atoms in your body were forged in stars. Let us stay with that idea, because it is not a metaphor. It is a description of what actually happened, traceable through chemistry, physics, and the long history of the cosmos. The two most common elements are hydrogen and helium. Hydrogen formed in the first few minutes after the beginning. Helium formed shortly after. Everything heavier, every element from lithium to uranium, was made later inside the cores of stars. The oxygen in your body makes up roughly 65% of your mass. It was made in the cores of massive stars. When those stars ended their lives, they released that oxygen into space, where it eventually became part of the cloud that formed the Earth. The iron in your blood is particularly well traveled. Iron is the end point of fusion in massive stars. When a star's core becomes iron, fusion stops and the star collapses under its own gravity in a fraction of a second before the outer layers explode. The iron in your hemoglobin was forged in the final moments of a massive star's life, scattered into space by the explosion, and eventually drawn into the cloud that became our solar system. The iron in your blood has already survived more than you can imagine. Calcium, which makes up your bones and teeth, was also produced in massive stars. Carbon, the backbone of every organic molecule in your body, was first made through a process in which 3 helium atoms fuse together inside a stellar core. Stars built life's foundation. Gold is thought to be produced primarily in the merging of 2 neutron stars. When 2 of these dense stellar remnants spiral together and collide, the event produces enormous energy and a spray of heavy elements, including gold, platinum, and others. Astronomers detected one of these neutron star mergers directly in 2017, observing it simultaneously in gravitational waves and across many telescopes. The event confirmed that heavy elements are genuinely forged in stellar collisions. The atoms were there in the data. Your body is a particular arrangement of matter with a very long history. The hydrogen has been hydrogen since the first minutes of the universe. The carbon and oxygen passed through stellar interiors. The iron was made in a dying star's final collapse. The atoms will not always be you. They were other things before, and will be other things again. But right now, they are here, in this body, In this room, arranged into a shape that can listen to the night, the universe has done something remarkable with very old material. Part 10. The Quiet Gift of Smallness. We have travelled a long way tonight, from the room you are in, out through the solar system, and across light years to the nearest stars, through the Milky Way and the filaments of the cosmic web, to the edge of the observable universe. Then we came back inward, past the cell, the molecule, and the atom, to the particles that make up everything you are. At every scale, we found the same quiet truth. You are somewhere in the middle of something enormous, and the enormous thing is mostly still. You are not at the center of the universe. No place is. The universe appears to have no center, or rather, every point is equally central. From wherever you stand, space expands outward in all directions. Your position is not marginal. It is simply one of countless equivalent ones. The inevitable problems that come along in life are real. I want to say that clearly, because this journey was never meant to dismiss what you carry. Anxiety is real. Worry is real. Perspective does not erase any of that. But perspective can do something that reassurance alone cannot. It shifts the frame without denying the picture. Your worries are the concerns of one person, in one moment, on one small world. They matter to you, but they do not bend the arc of the galaxy. The sun will rise tomorrow, whether or not you solved tonight's problem. The Earth will complete its orbit, whether or not things go as planned. The Milky Way will continue its slow rotation without any knowledge of what you decided, or feared, or hoped. Your smallness is not a diminishment. It is a permission. Permission to put things down. Permission to let the unresolved remain unresolved while you rest. The universe has been here for nearly 14 billion years. It will not be less patient for your having slept. The atoms in your body have survived the death of stars. The hydrogen in your cells has been hydrogen since the universe was minutes old. You are made of material that has already endured more than any worry you have ever carried. You are durable at your foundation. This is your moment, not the grandest in the history of the cosmos, but yours. The universe, vast and old and patient, is asking nothing of you right now. It is simply continuing, as it always has, while you take this small and necessary pause. The night sky is full of light that has been travelling longer than Earth has existed. It is not aimed at you, but it is here with you. The universe is a large and quiet companion, and tonight, in this room and this dark, it is simply here. And on that note, we come to the end of our journey. We travelled tonight from the room you are in, through the solar system and the light years between stars, past the Milky Way and the great web of galaxy filaments, to the edge of what can be observed. Then we came back inward, through the cell, the atom, and the ancient particles of which you are made. At every scale, we found the same quiet truth. Rather than being something to fear, the sheer size of the cosmos offers a kind of quiet relief, a reminder that our daily worries are small against something so impossibly vast. The scale does not erase your concerns, it simply holds them loosely, with enormous, unhurried space around each thing. Thank you for joining me tonight on the Nocturnal Astronomer. It is always a pleasure to have you here. I'll see you next time.